In this video, I'm going to do a bench demonstration of how temperature affects the ESR or equivalent series resistance of electrolytic capacitors using a couple of capacitors that I removed from a failed control board. Okay, I've got the bad capacitors out of the board here. And I'm going to do an out-of-circuit ESR test. This is one of the capacitors. Okay, it's saying an in-circuit leaky capacitor with an ESR of greater than 40 ohms. That's horrible. Should be less than 0.5 ohms, I would say, 0.5 or less. This is the other capacitor. It's saying open circuit or low capacitance. So basically this one is an open circuit. So these are definitely bad. Now this is a measurement of a good 470 microfarad capacitor. These are low ESR capacitors for power supplies, so this should give us a good reading. So it's reading 470.5 microfarad. This is a really good meter. I love this. And it's giving us a 0.41 ohm ESR, which means it's going to filter that AC out real well and provide a good strong current sourcing capability for that 12-volt line. Okay, so this is one of the capacitors from that motherboard, and this is a 470 microfarad capacitor. I'm going to do a bench test here. It is in series with a light bulb. I'm going to show how heating up will cause the ESR to drop enough to light the light bulb and actually give us a display here. This represents the voltage across the bulb right here. And I've got this signal generator set for 10 kilohertz, which is more than enough to make a 470 microfarad capacitor look like a closed circuit under normal conditions. So let's go ahead and zoom in here. So I'm going to go ahead and heat this up here with a hair dryer, and we'll see the light bulb light and the voltage across the bulb increase as the electrolyte becomes more fluid and more conductive. Okay, so the bulb is now lit, and you can see this is the voltage across the bulb, which is not enough voltage, not a lot, but enough to light this bulb. This is I believe this is a 4-volt bulb. So the capacitor is very warm right now, and I did speed that up because it was taking a long time to heat the capacitor up enough to make it conductive. Now I'm going to go ahead and cool it down with this freeze-it spray here, and watch how the conductivity completely drops off as the capacitor cools. So you see the bulb is getting dimmer, and our voltage has completely dropped off there. So there is no conductivity at this point. The capacitor is just completely looks like an open circuit, and the bulb has got no current flowing through it as a result of cooling it down. So electrolytic capacitors, their electrolyte will function better and conduct much better when relatively warm. But that's not to say that heat is good of course, for electrolytic capacitors. That is actually what accelerates their demise, is being hotter of an environment that they are in, the more quickly their electrolyte will evaporate and the capacitor's life shortened. So that's it for this video. I hope you found it interesting and informative. If you did, please give it a thumbs up and subscribe to this channel for more like videos.